these things easy. Internet makes these things easier to happen, but it's not also as big of a deal as if someone like that were to come in person. That would have been really unpleasant. Yes. Okay. Yeah, let's see. Okay, so we have a small group now. Does anyone have any specific questions so far on where we were? I could share this.
I have a question, if it is possible. The problem is the causal relation between, as far as I understand, the crucial problem is about the causal relation between, abstract thing and also spatio-temporal things. Okay, so mathematical objects are abstract, mind independent, etc. How can we apply these abstract things to the spatio-temporal area, right? So can we see, I'm not expert on, of course, Plato philosophy. Can we see any third thing in Plato philosophy, like like in Kant philosophy? For instance, Kant, as you know, Kant solved this problem with the schema of imagination. Schema has both intellectual part and also, essential part. So can we see anything like this in Plato philosophy?
Also, I would like to add something to this question of Erdal Hoca, if it is possible. Sorry. Can I talk or? Okay, thank you. As it is, because my question also is related to the same point of view that Erdal Hoca said. So as I remember in Politeia, Plato argues that actually all our knowledge or all our episteme is hypothetic in terms of the idea of good. And if I say in other terms, I understand as Plato says, of course, for mathematics also, the science of mathematics is not completed, is deficient, if we do not take account the idea of good as the principle of the all knowledge. So this discussion between outliers, the problem of abstract or the concrete, could be taught in the context of the source of any kind of knowledge. So what can we say about that? And by the way, I would like to say also something. For me, it was always difficult to understand what is concrete and abstract in mathematics. It is very discoverable. It's not net, as you know. So if you take a number, for example, a number in mathematics, how can you say it is abstract or concrete? You see what I mean? Yeah. So this discussion is something like for physics. If we take this discussion, could be more comprehensible if we take physics. But in mathematics, I think the entities are always beyond the concrete and abstract.
Yeah. Okay.
Is it not false discussion? What do you think about it? Thank you.
Yeah, I think, okay, many interesting points have come up. Yeah, I'm sympathetic to Kant's view, where I think that this Platonistic-ish question of the causal relation doesn't necessarily come up, because there is, I mean, in at least the contemporary debate, the abstract realm is mind independent, external, in a world which doesn't really necessarily make sense with Kant, because the world is in part determined in some way by also our conceptions. So I think one can perhaps sidestep the whole debate if one's thinking in other terms than just this sort of, quite a good question. What is abstract, concrete distinction? But because there's many counterexamples, if you want to say, oh, not spatiotemporal, what about the equator? It came to existence at a certain time, but it's abstract. So, but I'm just my purposes, I'm just understanding the distinction as extended or spatiotemporally extended, or even in space-time, having some type of spatiotemporal qualities for the concrete and not for the abstract. Of course, if you think of relational properties, and if we think that the abstract is causing something in the concrete world, then you might see sort of some spatiotemporal quality to the abstract. But it's difficult. Yeah, it's certainly a difficult I could just dive into the debate and accept where they're coming from, I suppose. I don't know if that responded to both of your comments in some way. I think I touched on some of the issues, but there was a lot there and I don't remember everything now. So right, the idea is supposed to be that there's this mind-independent abstract realm that's supposed to have effect on our brains somehow. If Platonism is true, the objection is supposed to be this can't happen though. And I want to say, well, according to what theory of causation can't that happen? According to Descartes' 17th century contact mechanics, it can't happen. But what about contemporary theories of causation? Well, Lewis's counterfactual theory of causation. Well, he does frame it originally in terms of spatiotemporally extended events. Okay, so that really wouldn't help the Platonist. He then revised it to account for spatiotemporally extended events or absences of such events. Okay, I mean, he allows for absences to be causally efficacious. Abstracta aren't absences, but absences also don't seem to be spatially extended, at least. So there's, it's not, that should sort of make us question at least, well, why should we have to say that causal relata have to be spatiotemporally extended? So how might one, though, work out a counterfactual account of abstracta being causally related? Okay, well, you might want to say, okay, so on a counterfactual account of causation, very roughly, if someone didn't throw the rock into the window, then the window wouldn't have broken. So the rock is therefore, the throwing of the rock is causally relevant to the window breaking. So the Platonist would want to say something similar, like if there hadn't been infinitely many numbers, natural numbers in the Platonic realm, then the mathematicians wouldn't have, then Gödel wouldn't have been able to perceive that there are. So they wouldn't have come up with this axiom of infinity. Okay, so, well, that seems to make sense of a counterfactual account of causation. However, there is a problem with this approach, and that is the antecedent in this counterfactual is thought to be impossible. And if you're like Lewis and think that conditionals with impossible antecedents are vacuously true, then well, then it's just as true that if there hadn't been infinitely many natural numbers, then mathematicians wouldn't have believed the axiom of infinity. But it's also true that if there hadn't been infinitely many numbers, this is impossible, mathematicians would have. So we don't get causation in that way. So that's the idea that counterfactuals with impossible antecedents, counterfactual conditionals with impossible antecedents are vacuously true. Vacuism, it's called vacuism. But that's been questioned by some. Not everyone accepts vacuism. Some people think that some counterfactuals with impossible antecedents are true and some are false. Daniel Nolan gives some examples. So, like he says, if Hobbes had squared the circle, that's impossible, then ill children who never heard about it wouldn't have cared about it. He says, that seems true. If Hobbes had squared the circle, then ill children who'd never heard about it would have cared about it. He says, that seems false, and we want a theory that can account for that. So if you follow Nolan, then maybe you could create a counterfactual conditional account of causation. The Platonists could adopt such an account of causation for abstract entities. You might not want to, and I think there are other routes to take for the Platonist. It is a controversial view, this non-vacuism. So you might instead, and I think this is reasonable for the Platonist who seems to say we have some sort of perceptual insight into the Platonic realm, to not say, and here I'd be interested in those who are mathematically inclined, well, that the axioms themselves, what follows from the axioms follows necessarily, but that the axioms themselves are contingently true. So it's not the denial of a necessary truth to say that there are only finitely many natural numbers. It's a denial of a contingent truth, so we don't have vacuism. So I think that could be another realm, another route to go. And I think if you follow Gödel's sort of view of perception of Platonism, where the mathematician has perceptual insight, then it seems natural. Another way to go. Okay, I should stop for comments, and I haven't shared the screen again since, I don't know, that might have caused problems or something, but I should stop for questions. Or so I'm trying to say, I think you can look at causation, look at the contemporary rate, and the Platonists could make sense of causal relations between abstract and concrete, given the way causation, not always, but there's no, okay, this leads to my next point. There is no agreed upon conception of causation, and this leads some to accept primitivism. Causation is just a primitive relation. So a number of people have argued for that. Makes it pretty easy for the Platonists then to say it's just a primitive relation that the abstract causally affect us. Hartree-Field says, oh, this is ad hoc. It's, fine to sort of take some relations and properties as primitive, but for the Platonists to do this, it's just not acceptable. Well, I think that if if there was a widely accepted view of causation, a theory of causation, then for the Platonists to say, oh, it's just primitive, then that would be ad hoc. But given that primitivism is one of the options, and there's a number, this is what's without my notes, I don't remember all the names now, of people who accept it, doesn't seem so ad hoc to me. But I think there's another approach, I think, and I think this would be, like if I were a Platonist and wanted to sort of defend the view, this is how I might think about it. Sort of mirroring my view about the mind. Well, you know what? We just don't know yet. We don't know how this causation works. And if it's something real in the world, well, we should try to figure it out. There's lots of things we don't know in the world, but it doesn't mean they don't happen. I mean, my favorite example is always that we actually don't know how. There's hypotheses about this, and they do make sense. You know, these hypotheses do make sense, but it's not known how cats purr, not even why, but just the mechanism. We don't actually know for sure. You think it'd be easy to look into that. You just do MRI or something, but it's not known how it works. So, you know what? We don't know how the causation works, the Platonists, I think, could say. It's going to be, we don't seem to have a perceptual organ, though. Like we have our eyes for vision, nose for olfaction. We don't seem to have a perceptual organ for abstractception, one might call it, perception of abstractness. Physiologists do talk about chronoception, a perception of time, and that isn't associated with a perceptual sensory organ, a specifically dedicated organ. So it might be something more like that. So I don't think that it excludes the possibility that we could have some type of perception of abstract entities. Okay, so Sunam, I'm noticing there are people in the waiting room. You're taking care of it, right? If they're acceptable or not.
Yeah, well, those we are.
You're questioning them. Yeah, I'll just close it so it doesn't like. So I think there are reasonable ways the Platonist could go. So that's sort of the argument. What I wrap the paper up with is, this is always important, and somehow during this time of crisis, everyone's been, why does it matter? We've all been wondering that, even just now we got kicked off with all this, and I just thought, why does this all matter? Like, we're thinking about abstract entities, and can they be causal linked? Well, Penelope Maddy argues, so she's one of the central philosophers of mathematics, and she thinks that these questions are just they're not of importance to mathematicians, and that philosophers of mathematics should focus on questions that are relevant to mathematicians. So I agree that that is one useful and interesting way to approach philosophy of mathematics. And in my work in philosophy of mind, I have often, my book on expertise, my 2 books on expertise, they are relevant. I think they're relevant to actually practitioners. I think that's fine, but I don't like saying that that's the only way the inquiry should proceed. And I think there's room in the debate. I think these ontological questions, they are of interest to people, of metaphysicians who are interested in the fundamental nature of the world. And I do think that for some mathematicians, like Hugh Wooden, set theorist at Harvard, that the Platonistic issue is relevant. I think he is motivated right now in his work. Maybe this is something that happens later in life, and when one becomes more philosophical, but he is interested in whether the continuum hypothesis is, regardless of whether it might be independent or not, whether it actually is true or false. And I think that, and he's been writing about that and thinking about that for a long, long time. And what motivates him? Well, it must be some sort of Platonistic view that there is a mind-independent realm that in which it actually would be true or false. So I think it can actually be relevant to the practice of mathematicians, these issues. But I think that's it. Okay, thanks.
Can I ask another question?
Sure.
Thank you for this explanation. It is very open mind, for discussion. But for me, I'm not sure about the discussion. This discussion, when we discuss the Platonist mathematical weave, by separating his idea of mathematical object from his metaphysical background. For instance, perception requires a spatio-temporal relation, perhaps. But when we discuss Plato's mathematical ideas based on the idea of perception, I think we reduce Plato's idea to, perceptionist perspective. As you know, for Plato knowledge, episteme is not based on perception. Episteme is anamnesis. We discover that. So it means, when we discover that, it exists. These things exist within us. For him, of course, within the soul. Because of that, we discover that. We don't invent them. So I think when we based on the, when we discuss this issue based on perception, I think we reduce this metaphysical, the relation between metaphysical background and the epistemological, area to the just perception, I think. So can we understand Plato's mathematical opinion by separating it from his metaphysical background, the Plato's metaphysical background? As you know, Demiurgos shaped the matter by using the number, imitating ideas. So there is a metaphysical background, I think, grounded these mathematical issues, mathematical area in Plato's philosophy.
Yeah. Well, okay, there was a lot there, of course, and I'll pick up what I can, and then you can see if I'm getting what you're saying.
Yes.
As I'm thinking about it, so Plato does, and Banas hypothesizes that Plato brought in the whole idea of we have knowledge is memory, that we're just remembering something, because he thought there was a problem of knowledge sort of having a sort of causal relation between the forms and us. How could they causally affect us? So this is Banas hypothesis. So he turns to memory. We remember them. Well, I mean, possibly. I don't know. I don't know Plato's intentions there, but nonetheless, he does seem to think that the forms play a role in making something beautiful. And that's not because my vase or whatever is beautiful remembers this form of beauty, but somehow it makes it beautiful. It participates in, I'd have to brush up on in beauty. So there's some sort of quasi-causal or some sort of causal connection there. But yeah, it does seem in Plato, I think, as you were saying, that it isn't just reduced to perception, right? So, and maybe you want to say this is where, Gerald Katz, who calls himself a Platonist, or did, and he rejects this model of Platonism. So he thinks that the intuition, insight, it's not perception. He says that's it's sort of an unduly empirical type of model of thinking of Platonism. So that might be another way. What I'm trying to do is, even on the empirical model, I don't think there's necessarily a problem. I mean, I tend to be drawn to the more, if I were a Platonist, I think I'd be more than the empirical model, because I do tend to sort of lean towards that. So, but yes, you might think that this approach to Platonism is mistaken, certainly. Yeah. If that, let's get into.
So
Can I ask a question again?
Let's see, Karen had a hand up,
Yes.
but if you have a, did you want, if it's a follow-up maybe, or, yeah, okay, okay. Karen, do you want to?
yes,
Alyssa,
maybe Ali Said Hoja has a follow-up question, and then I'll go next.
Okay, thank you. I ask a question. First of all, thank you very much for this great presentation about very important subject in philosophy, as I understand, in modern philosophy. And as I understand, well, all of metaphysical or epistemological questions derived by this mathematical issue about abstract or concrete, or about the origin of the mathematics. So if I understand well, you find the Paul Banas challenge as a weak challenge, right? It's not very powerful, if I understand it, according to you. I would like to know, why is it weak, not powerful theory? In short, a fifth sentence, by a fifth sentence, please. And my other question is more general question. What do you think about the origin of mathematics? I think it is more important question than the question of abstract or concrete. According to Plato, if I understand well, the origin of mathematics, or even any kind of knowledge, couldn't be in perception. This is very metaphysical argumentation, but it is also the foundation of all of Western philosophy, all of the Western idealism and metaphysics. So this question about the origin of mathematics touches all of metaphysical possibility of the question of the science. So what would you think about it, about the origin of mathematics? How could we have mathematical intuition, mathematical theory? The perception is, I agree with you, the perception is very weak for explaining the origin of mathematics. I perceive something, okay, the things, etc., but how I can create or function the mathematical entities in perception it is enigmatic. It's not easy to understand by perception. Yeah, thank you.
Yeah. Okay, that second question is going to be hard, but maybe something will come to mind while I'm answering the first one. Yeah, so why is it a big question? And I mean, that it's big is just is attested to in the literature as it's described as the focus of attention in philosophy of math for the past 50 years. Maddie gets upset that it is, but she admits that it has been the main, but why? You didn't ask that. You weren't questioning my that, but you're questioning why. Why has it captured? Well, I don't know. I mean, in part, it just has the classic sort of makings of these philosophical conundrums where we take, I mean, I'm sorry if this is a little cynical, I guess, but where we take concepts that we don't quite understand, the causation, and we create an argument, and there's a sort of clear argument where there's this causation and abstract, where there's these terms that we don't quite understand, and just seems to be sort of the classic philosophical interest. But yeah, it's an interesting question why it became such the focus. I mean, it's a sort of interesting question of philosophical sociology of the debate in philosophy of mathematics. Yeah. Okay, so I don't really know, but that's a little analysis. As to the origin of mathematics, well, I mean, now who was it that was talking? Maybe someone can say something. I didn't see who it was when I was giving the talk. I just heard the voice. But about, I mean, there are investigations by psychologists, developmental psychologists, into how children learn. Someone was bringing this up, and learn mathematics.
Yeah, it was Aaron, and he's right here.
Oh, okay. So maybe he's gonna. So let's. I'm gonna let Aaron say a little bit about that. But maybe we can. I think maybe Karen, we should move to next. The origin of mathematics. I mean, yeah, it was another interesting related to that is right why it evolved. If somehow thinking about infinity it doesn't seem to be evolutionarily advantageous, but maybe it was a spandrel, or maybe it wasn't. So it was a spandrel, and then now it's developed, of course, some type of, maybe not of course, but maybe some type of advantage. It would get you tenure or something. Okay, so, but I'm gonna hold off on that, and maybe we can have a discussion on the origin more with Aaron, but let's go to Karen.
Okay, thank you. So I have a very different sort of a question, I guess. So I understand that, I understand how, let me put it this way. You showed in the talk different routes that the mathematical Platonists could take, and that as a result, and the possibilities of these strategies, routes, possibilities makes it, debunks or weakens, let's say, the metaphysical premise, the claim that in principle, impossible for, okay. But also at the beginning of the talk, you mentioned that you're not defending the mathematical Platonists, you're just shifting the burden of proof, right? And I don't understand why making it, let's say, merely possible shifts the burden of proof. I mean, and it can still, the burden of proof might still be on the Platon. It depends on how strong these routes compare to the other routes. I mean, you can think of many examples, just a simple one because of the, contemporary issues. You have someone can use this strategy and say the mere fact that there is a scientist who think it's merely possible that climate change is not real, then the burden of proof now is on the entire scientific community to prove that it is real or something, Yeah.
Yeah, no, that's a good point. I mean, okay, so I've been struggling a lot with formulating this dialectic, and maybe that is not, okay, first thought is maybe this is not the best way of presenting it as shifting the burden of proof, but it is, okay, so if as Hartree-Field says, the problem is that it seems in principle impossible to do this, I'm at least getting rid of that problem. Maybe there's another problem. But that's the only problem that's been presented so far. So with climate change, I mean, there's more sort of that's been presented. The main problem that has been presented in the Banas debate is that it seems in principle impossible for the abstract. Maybe there's an argument that it is in principle, that it is not just seems, but it is. So it's a very weak claim. It seems in principle impossible. So I'm just, so in that sense, so now I'm going to say, actually, I do think it's a shifting of the burden of proof. Okay, so the field is saying it can't, let's see, saying it seems in principle impossible for the abstract to have a causal effect on us. Therefore, Platonism is false. Well, I don't think it does. Show me why it does. I've tried to give you reasons why not necessarily that it is possible, but at least it doesn't seem in principle possible. Maybe you still think it is. So I think does that make sense?
Yeah, I mean, yes, it does. I mean, it's just that I think just because when it's formulated in terms of the burden of proof, I think the narrowness, because you do narrow what you are focused, your focus is narrow in the paper, and then I mean this is my opinion, I don't know, but when the claim is about shifting the burden of proof, then many other considerations has to be taken. Are there, for example, what are the benefits of Platonist mathematics? What are the other positions that are there, etc., etc.
Yeah.
So this is why for me it seems that okay, it's fine. Now it's a possibility, but we just have to hold on until
Yes, good. So in the paper, what I do say is, assuming that, not taking into account the Banasaraf argument, there are good reasons on balance to accept Platonism. Then there's still that. So yeah, I do say that. Let's assume, because there's lots of other reasons to reject. So yeah, so I think I had a lot of trouble formulating that. So I'm going to go back and carefully check how I have presented the dialectic, because somehow it's been difficult. But yeah, thanks. Good. Can we move to Aaron?
Okay, am I audible? You can hear me. Okay. Well, thanks for introducing these questions. I feel a little embarrassed because I've been thinking for so long about so many of these questions and their relationships to other things that haven't come up. But I don't want to sort of take over and produce a whole lot of stuff, but I'll try to pull out a few key points that seem to me to shed light on the issues that have come up today. And you may or may not agree. One is that there are types of structure. There are spatial structures, there are logical structures, grammatical structures. There are structures with metrical properties like geometric structures, and some without, topological like containment and contact and so on, where there need not be any a measure of what's being discussed. It's just there or not there. And humans have discovered many of these systems of structures and relationships over many years. And I now want to add that I believe there are many intelligent species that share with humans the ability to detect instances of these structures in the environment and to make use of the possibilities and impossibilities in deciding what to do. I don't know how many of you have seen videos of squirrels defeating squirrel-proof bird feeders. You know, lots of people put up stuff for birds, and then squirrels get the food. So they try to design a better bird feeder than the squirrels investigate for a while, and then find out how to get around it. And that illustrates their ability to discover possibilities and to make use of them, which the designer of the feeder had not noticed. Although the designer might have noticed if he'd pretended he was a squirrel and played. Anyway, that's another issue. So it's not just humans. And that raises questions about how biological evolution was able to produce these abilities, and other questions about how they're actually implemented in the brains of squirrels and other animals. And those are all very complicated questions to which I think nobody has deep and complete answers, but I think we can say a few things about them. For example, human children seem to have an ability, as the squirrels do, to detect that some things are possible and some things are not possible, to make use of that in taking decisions about what to do and so on. But they also have abilities to extrapolate beyond the ones that they've already encountered. And when they meet something new, they may, for instance, try to push something through a hole, and the hole's too small and the object won't fit in. And from that, notice for the first time, perhaps, that situation can arise. But the next time they want to move something through a hole, they may notice immediately that the hole is too small and not have to discover the impossibility, because they recognize it as an instance of what they had previously encountered. And how that works would depend on facts about how brains work that I don't think anybody probably understands at the moment. But biological evolution produced many things people don't understand. I will add a little more about evolution, which I think is relevant to this. There are many things that evolved because there were problems, and only species that could overcome those problems could survive, reproduce, flourish, or whatever. And so the fact that the genome could play with various combinations of features in the normal biological random, semi-random variation means that it's just luck that for some species that they develop those abilities. But I think there are also some abilities that are much more abstract that some species have and humans have to a very high degree, and other species not so much. For example, the ability to consider whether a problem is of the kind that I've just been talking about. They start trying to solve a problem and then can step back, and if they've been having difficulty, can ask, is there a solution that's possible here? And that can come up in many practical applications, practical activities. If you're trying to build something and you're trying to make it serve some function, or you're trying to build something, you make it, you use it, and then you find it has a side effect. Then you want to think about, could it be changed in such a way that it preserves the desired effect, but doesn't allow the side effect? And I suspect just from my verbal description, you can probably, if you go away and think about it, come across examples in everyday life where there are problems of that sort and people solve them. But some people also step back and think about what they've done and try to generalize it, and may even decide that they want to try to save other people the trouble of discovering it through failure and teach them in advance. And a lot of our educational system is based on the desire of adults to enable children to avoid having to go through all the discoveries personally that adults in the past or others in the past had to make. And one of the things that comes out of that is that sometimes you can teach people that things are impossible, or that certain things will necessarily have various consequences, and give them an insight into how that works. Now, I think that there's a great deal of mathematics that has those kinds of formal features and get put into mathematics syllabuses and then start getting extrapolated by mathematicians who are not so much concerned with how is this useful or not useful and when might I need it in engineering, but just because they become interested in those mathematical structures and how some structures can be related to others. And if you've sat in pure mathematical discussion or in a lot of theoretical computer science is like that nowadays. So I think there are these spaces of possibilities and impossibilities where there are relationships between structures, and some kinds of cognitive abilities are available to humans that not other species have, and there are some that we share, in particular the ability to detect instances of impossibility, whereas I don't think a squirrel will necessarily be able to generalize in the way that the human can. For instance, I doubt that a squirrel can express to its, I could be doing an injustice to squirrels, but I suspect no squirrel has the cognitive resources to express the fact that containment is transitive, that if A contains B and B contains C, then necessarily A contains C. If that's spatial containment, there might be other kinds of containment. And very young children don't have that. They're not born with that. But something develops later, and I don't believe at the moment that there are developmental psychologists and brain scientists who have very good theories about what those processes are, but we may get some later on. Anyway, so I think a lot of what you've been talking about has deep connections with evolution, products of evolution, facts about particular species and what their history is and what they've discovered, facts about social systems that humans have developed for teaching what has been learned in the past, but also facts about systems we've developed for teaching people so that they can make new discoveries that haven't been made in the past. So if you go and do a degree in mathematics or in theoretical computer science or whatever, you're not just taught what has already been learned, you're taught to ways of thinking. And it's a fact about biological evolution, which is a very obscure fact and it's not easy to explain how it's implemented in brain, that humans have abilities to extrapolate and extend and generalize these things. And that leads to all kinds of branches of mathematics. Anyway, I think all of this is sort of relevant to what you're saying and provides a context which I suspect could allow some of your questions to have answers, but sometimes the answers would say, well, we have to do a bit more research on that. We can't just do that right now. And I just must apologize for taking so long to say all that. This is part of a very long-term research project, and I've only given you a tiny fragment.
I found that so fascinating, and I would love if my work had developed along those lines, more empirically. No, thank you. I'd like to hear more about your research too, so send me something. Yeah, I have a mental note. I didn't even know how tempted I was to check
I'll
online.
put my email address in.
Okay, even though I was very tempted to look online for that, those how squirrels can figure out the squirrel-proof bird feeders. I haven't looked it up yet, but I'm going to. So that's very interesting. And then I was also, well, I think right, your comments about possibility were very interesting, made me think if they're relevant to the philosophical methodology of thought experiments where we're thinking about what's possible and not. And I thought about also my cat, who does have a sense of what's possible or not with the toy when it disappears. And when it's an actual mouse, well, not an actual, toy mouse on a string, she knows that it's going to come out the other side. But then we actually have, although we shouldn't, I think it's right, as my son said, he really shouldn't use this, the laser pointer, which doesn't follow those rules, but she expects it. If I make it go under, she expects it still
Cats love
to
to
come out.
follow light spots.
Yeah. So, but it doesn't follow the rules of it could disappear. Physical sort of. So she generalizes from what she learned with the toy mouse. So so there's many. So thank you for the thought-provoking comments.
Since you mentioned cats, there is a famous video of a cat with a corn cob in its mouth and a gate with vertical bars. And someone was riding a bike or something and saw what was happening, which I'll tell you a bit more about in a minute, and then came back and videoed what I'm now going to describe. This cat kept trying to get through the bars, holding this thing in its mouth and failing. Okay. And there are also videos of dogs like that. They carry a stick, try to get through a gate, and they can't. This cat just kept trying and coming back. And then at one point, it somehow shifted its grip on this corn cob. So it was holding it closer to one end instead of in the middle. And then when it went between, it tried to push itself, including this thing, through the bars, the fact that it wasn't holding it parallel meant that it was able to get its head through and drop the thing on the other side. And then I think it went through, I can't remember the details, but anyway, after that, it was happily ran off. Now, whether it would remember or recognize what it had done and why it had failed, if it came back next time, I don't know. I doubt that. But there are other animals. There are sheepdog. There's some species of dogs that are very bright, and others not so bright. And I think the sheepdogs are able to learn all sorts of things about structures and relationships that some other dogs are not able to learn. And there are huge varieties between other species. And in particular, there are differences among birds. I'll just give you one last observation because I've been thinking about it a lot recently, and I think it's full of rich implications. There are some species of bird, avocets are an example, that soon after they have hatched can act in the environment in quite intelligent ways. They don't have to learn. So in particular, there was a BBC Springwatch video in June, and I've got a clip from that. If you email me, I can send it in 35 seconds, showing newly hatched avocets. They've come out of the egg where they've been in for several weeks. They've gone to the mother, and then the mother at one point has several of these, all the eggs have been hatched. She stands up, goes that way, and the 4 chicks go in the opposite direction to where there's water. And then they go into the water and start pecking and feeding themselves and strutting around and so on. Now, there's no way they could have learned to do that after coming out of the egg and going to the mother. That means that the chemical processes inside the egg that assemble those animals must somehow have created in their brains the ability to cope with those situations. And I don't think anybody at the moment knows how that is possible. So there's an example of possibility and impossibility. That's a deep research problem that I'm struggling with. And I'm hoping that some of the biologists and biochemists and people that I talk to will come up with clues. And it'll show us perhaps that there are things about the way evolution has used chemistry that are deeply connected with having our ability to have mathematical insights. And I'll just leave you with that thought.
So fascinating. Thank you. Yeah, I'll send you an email to get more. I have to get some links to those videos. Great. Well, if maybe there's no other questions.
I believe so.
Yeah.
Thank you so much, Professor Montero, for this talk.
Thank you.
Well, thank you. Thank you for coming back and making it through.
Thank you so much. Thanks so much.
Okay, thanks.
Thanks for letting me in. Yes, thanks.
Yeah, thanks. Okay, we'll be in touch. Thank you, Sunam.
Okay, bye.
Yeah.
And nice meeting you all.
Have you had a chance to copy Aaron's email? It was in the
Yes,
chat.
I did.
Yeah.
I did. I copied it. I did. I put it into already
I have
an email message.
Perhaps I should warn you, you may or may not be able to guess my age, but I've been using computers for very many years and trying to combine my interest in mathematics, computing, and the internet when that became available. So I have a huge amount of stuff available online. And if there are things you particularly want to explore, you can email me and I may be able to say, I've got a partial answer. I don't have full answers to any of my questions yet, but I can point you at lots of partial answers if you're interested and have the time. And
Okay.
this is a way in which I may recruit some very clever people to add things that I couldn't possibly have thought of on my own.
Wonderful. Thank you.
Okay.
Okay. Okay. Well,
Okay.
thanks, everyone. See you
Bye.
again next time in person.
Yes, hopefully. Have a good evening and have a good day to everyone.
Okay, thank you.
Who goes first? Okay.
Bye.